Welcome to our channel. Watch the video until the end, leave a like, and subscribe to the channel to support us. The latest discovery by the James Webb Telescope could change the universe. 6 strange light phenomena are currently presenting researchers with an unsolvable enigma. What is the James Webb Space Telescope really showing us? Initially, researchers said these mysterious light signals were galaxies, but doubts about these theories have since arisen. What are we actually seeing at the edges of the observable universe? Are they traces of another dimension that prove our world is completely different from what we thought? And do these light phenomena provide the first real proof that our universe is just one of many? Have you ever looked at the night sky and wondered what you are really seeing? You might spontaneously say, "Of course the stars, but that's only partially true." Yes, you can see the light of many thousands of stars, but also some galaxies, bright planets like Venus or Jupiter, and of course our moon. But you are also seeing the depths of the universe and the past. None of these stars exist today in the places where you see them. They have moved away long ago, and you are only seeing their light that was emitted at some point in the past. Light takes several years, or even millions or billions of years to reach us near Earth. You might see 2 stars in the night sky that seem close to each other, but in reality, one star might be very close and quite dim, and another star that appears right next to it could be hundreds of light years away. It appears similar to its apparent neighbors only because this star is perhaps much more luminous, and so we receive the same light from it, even though it's farther away. It's a bit like seeing an archipelago of islands from a ship in the distance. From afar, some islands may seem connected to each other like a chain, and it might seem that you could swim from one island to the next with just a few strokes. When you get closer, however, you realize that the distances between the islands are greater than you thought, and that they could hardly be covered by swimming. Keep this in mind when you look at the night sky. Perhaps you will suddenly perceive more spatial dimensions of the universe, and the seemingly two-dimensional carpet of twinkling lights will become a tangible space. However, you must not forget that you are still looking into the past. You are looking at a light imprint, not reality. Galaxies so ancient that they explode the universe represent a turnaround like none seen in science for a century. With its ultra-sensitive infrared technology, the James Webb Space Telescope blows up everything we have been able to observe in the universe. Webb is able to detect light so fine and subtle that our human eyes could never perceive it. However, even this technological marvel can only record light that has traveled through space for a long time, meaning the telescope can only imagine the past. Imagine the night sky again. There are thousands of stars, all at different distances. The larger and more distant stars may appear closer to our eyes than the dim and close ones. And today we do not know exactly where these light sources are. Webb works similarly to our eyes, only it sees the light trails of stars and galaxies that have traveled for billions of light years. In this way, the very ancient light sources, from our point of view, appear in the background of the image. The first image released by NASA in the summer of 2022, after the launch of Webb, was a deep image of the universe. Here we can see again the technology and effects of light travel very clearly. To achieve this brilliance, researchers exposed an almost empty area of the universe in the foreground for a period of hours. The telescope collects the faintest traces of light from the background of this area. If we were to look where this image was taken, we would probably see only a dark night sky with very few stars or none. Thanks to the absence of foreground interference sources, the oldest objects in the background become visible. In this case, they are orange or reddish light sources. The colors are caused by an effect that scientists call redshift. Due to the long journey through time and space, the light shifts toward a reddish color. Redshift also occurs because the sources that emitted the light so long ago have spatially moved away from us due to the expansion of the universe. The rate of redshift is therefore a perfect indication of how far an object actually is and how long the light has traveled to us. Scientists use this effect to determine the age of light sources, and in the case of this deep image from Webb, there were some surprises. The first confirmed light source, which is likely a galaxy, was an object with a z-value of 11. This data places it at an age of 13.5 billion years. This means that this light source already existed 300 million years after the Big Bang, and here lies the problem. In this era of the universe, sources of light of this type and size should not have existed. Mathematically speaking, we find ourselves in a time when at most the first stars and star clusters were forming. However, Webb analyzed this light and concluded that these were already very massive, luminous, and surprisingly well-developed galaxies, which absolutely contradicts the idea that these galaxies were among the first in a still young universe. Shortly after, another entire galaxy appeared that even had a Z-value of 13, thus shining bright and perfectly formed in space, just 200 million years after the Big Bang. These startling discoveries were followed by more in the months after the initial sensational reports on these impossible, universe-destroying galaxies. The media has circulated images of 6 candidate galaxies. These potential galaxies are called candidates because it has not yet been possible to confirm 100% that this light was definitively emitted by galaxies. And here we arrive at an exciting point. If these are not galaxies, what are they? 6 galaxies from a mirror universe? The fact is that we still don't know how big the universe is and whether it has a boundary. We have not yet found a spatial boundary. We look about 46.5 billion light-years in every direction, thus having a view of a space about 93 billion light-years across. But as we've said, we're always looking into the past and not at spatial reality. No boundary has yet been identified, and there are no concrete indications regarding this. All theories about this edge or boundary are ideas or speculations. With our theory of the universe's inflation and the Big Bang, we thought we had found at least a beginning in time, but on closer inspection, these were also just theories and speculations that made sense from a mathematical and physical standpoint, but lacked real proof. Webb was supposed to provide these, at least to the extent that the new telescope could show us the earliest epochs of light generation in space. But instead of the first faint light sources and chaotic star clusters, the telescope is showing us presumably perfect galaxies with a surprisingly ancient look. Following these discoveries, the scientific community is in turmoil. Some have proclaimed the end of the Big Bang theory. Others argue that galaxies formed much faster than previously thought, and still others have drawn up completely new calculations on the age of the universe. The situation becomes particularly interesting when these light sources are interpreted as references to theories of quantum physics, in which the universe has long been an undeniable truth and other dimensions, temporal overlaps and variability of realities are practically proven. Thus, we might be seeing perfect galaxies because we are not looking at the beginning of our universe but a mirror dimension. This idea is truly fantastic and was further fueled when researchers announced the existence of the Schrödinger galaxy, or Cheers 1749. Measurements of this galaxy showed the incredible fact that it exists in 2 positions and at 2 times simultaneously, which very closely resembles this property of quanta. These tiny particles of matter also have the habit of being fixed in time and space only when determined by a measurement. It is possible that the Big Bang never happened, and that instead of a temporal beginning, the transition to a parallel world is taking place right at this threshold. We will need further observations and measurements to confirm this. Now let's look at how the James Webb Space Telescope reads incredible details from the light. The light from these 6 mysterious light sources appears at first glance tiny, blurry, and meaningless, but for Webb, the light is full of information. Even in quantum physics, light is the messenger vector of information in space. At some point, this light was emitted by objects that could contain several million stars, and even at these enormous distances, the information has been preserved. We could never recognize or read them with our own eyes, but Webb can do it. Its ultra-fine spectrometers break down the light signals into their individual frequencies, and in this way, the telescope can provide information about the intensity of the light source, the elements present, and other important aspects. All of this is fantastic, but Webb cannot provide all the details at these vast distances. For example, it is still unclear whether these objects are indeed normal galaxies. The immense light could also have been emitted by gigantic black holes. Some active galactic centers contain black holes and quasars that shine brighter than an entire galaxy. The light is produced by matter accumulated there, which is heated by the power of black holes and quasars to the point of shining brighter than millions of stars. Is this the solution to the mystery? Here we are not seeing galaxies but black holes. The explanation could be plausible, but there is still a small problem. Even quasars and black holes of these enormous dimensions should not have existed at the beginning of the universe. This raises further questions about the accuracy of our current cosmological theories and our understanding of the primordial universe. Faced with these enigmas, the scientific community is pushed to reconsider some of the fundamental concepts of cosmology. The presence of these gigantic and mature structures so early in the evolution of the universe might indicate that the processes of galaxy formation and black hole development are much faster or different than previously thought, or that there exist unknown mechanisms that accelerate cosmic maturation. These discoveries could also suggest the existence of islands of early maturity in the universe, where particular conditions have allowed for galactic formation and black hole growth on much shorter timescales compared to the rest of the universe. Such regions could provide new windows into the physical processes that dominated the early moments of the universe, offering crucial clues for solving some of the most pressing issues in astrophysics and cosmology. Moreover, exploring these anomalies with the James Webb Space Telescope, JWST, pushes the technology to the limits of its capabilities, demonstrating how vital it is to continue developing new tools and technologies for space observation. Each new discovery opens up new questions and invites a deeper examination of the universe. The JWST has already shown that the universe contains mysteries we hadn't anticipated and that challenge us to rethink our existing theories. This is the allure of space exploration and science. It not only finds new answers, but also provides us with new questions to explore. The challenge now is for astronomers and theorists to work together to interpret these observations and integrate them into a coherent framework that can explain not only the existence of these early galaxies and black holes, but also the broader implications for our understanding of the universe and its fundamental laws. This process of learning and discovery will continue to evolve as we receive further data from the JWST and other advanced telescopes and instruments in the future. Every piece of information brings us closer to understanding the great puzzle of the universe, even as it reminds us of how vast and mysterious the space that surrounds us is. And in this era of unprecedented discoveries, we look forward with anticipation to many more exciting videos and reports on the latest findings from the frontier of cosmic exploration.